Well, hopefully the audio on this one will come out a little bit better than the last one. I don't know, I'm having a little trouble today. I don't know what's going on with my setup. But I'd like to go through the last section of Chapter 1 today, and then we'll take a look at some homework problems to do. As I said, that section 1.5, I went through the first video. 1.6 is properties of exponents. We've already talked a little bit about them, but it's good to review them, and also dealing with scientific notation. So exponents. Okay, once again, an exponent, if I have some letter or some number a raised to the n power, I'm just multiplying that number by itself n times. N times, or a times a, all the way up to the nth a. So as a more concrete example, if I have a to the fourth, it's just a times a times a times a. No big deal. You know about exponents. And I want to remind you of the rules for exponents. The rules are very straightforward. If I have a to the n times a to the m, that's a to the n plus m, where a is your base number. So if I've got, say, 2 to the fourth times 2 to the second, well, that's going to be 2 times 2 times 2 times 2, that's that, times 2 times 2. 1, 2, 3, 4, 5, 6, that's equal to 2 to the sixth. And that's the same thing as saying 2 to the 4 plus 2 is 2 to the 6. So when we are multiplying numbers with the same base, a to the n times a to the m, that's a to the n plus m. So that's easy enough. And we can go ahead and use this in even more complicated ways. So for example, if we have some things that I'm multiplying, like let's say I've got 6x to the fourth y cubed, this is an example out of your book, times 5x to the second y to the seventh. We're multiplying these two things, although it looks like a rather complex thing. Well, we multiply the number part. 6 times 5 is 30. X to the fourth times x to the second is x to the sixth. I'm just adding the exponents. Y to the third times y to the seventh is y to the 10th. So there's your answer when dealing with that. So that's the product rule. Quotient rule is very easy. Quotient rule is just a to the m divided by a to the n is equal to a to the m minus n. So you can have a rather sophisticated looking problem. Let's say I've got 30 y to the 9th x to the 12th over 5 y to the 7th x to the 3rd, and then we just go ahead and we do it one piece at a time. You've got 30 divided by 5, which is 6, and y to the 9th divided by y to the 7th, so 9 minus 7 is y squared. X to the 12th divided by x to the 3rd, 12 minus 3 is x to the 9, and we have our answer. That's our simplified answer. One thing I want to tell you is that a to the minus m is equal to 1 over a to the m. So if I have a to the minus third, that's equal to 1 over a to the third. So you just want to keep that property in mind as well. So the tricky, not tricky, but like a little trick that you might see something like this, you might have, let's not use a, let's say x to the fourth, y to the third divided by x to the minus 2 times y to the second. And we want you to reduce that. Don't forget, if I have a negative exponent in the denominator, we're going to bring that up to the top. So that's going to be like saying x to the fourth, y to the third, x squared over y squared. And we can just go ahead and do our thing now. We go x to the fourth times x to the second. That's x to the sixth. Y to the third. Excuse me. y to the third divided by y squared is just going to be y. So that's how you would do those types of problems. Don't forget, anything raised to the 0 power except 0, not good looking 0, a to the 0 is equal to 1. Doesn't matter how complicated your expression is. I can have 6x cubed y to the 5th z, and it's all raised to the 0 power. Boom. We're done. It's equal to 1. Which steers me in the direction of the power raised to a power. If I have a to the m raised to the n power, I just multiply those, and it's going to be a to the m times n. So if I have a situation where I've got 2 to the 4th to the 3rd, raised to the 3rd, 4 times 3 is 12, that's 2 to the 12th. And all of these rules are listed on page 77 in your book. You can go through ahead and look at the examples, and they're not too difficult to go through. We can take a look at a couple good ones here at the end of the chapter. Let's see here. Let's just try one or two here. How about this one? This is one from on page 76. They ask you to simplify this. We've got 2x cubed over y to the negative 4th, all raised to the 5th power. Okay, now we could approach this a couple different ways. Y to the negative 4th, I would probably bring that up into the numerator before I took care of this 5th business. So that's going to be 2x to the 3rd, y to the 4th, and that raised to the 5th power. So we're going to have 2 to the 5th, x to the 15th, y to the 20th, and 2 to the 5th is what? We got 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 32, x to the 15, y to the 20th. That'd be your answer there. So you'll have a chance to try a bunch of these when you do your homework. Okay, finally, last couple things in the chapter. They want to talk about scientific notation. Scientific notation is taking a number between, it's got to be greater than 1, but less than 10. So x is greater than or equal to 1, less than 10, and you're going to raise that to some power. And it's a way for us to take very large numbers or very small numbers and go ahead and express them using scientific notation. So let's say I have a number like 64 million. 64 million. Certainly I could write that out, but if I want to express it in scientific notation, what you're going to do is you want to get the first non-zero digit. So you want to have something to be like 6.4. That certainly meets this criteria here. It's criterion up here. And then we have to multiply it by some power of 10 to get this number. So I'm going to count over from where my imaginary decimal place is. 1, 2, 3, 4, 5, 6, 7 times 10 to the 7. So that would be my scientific notation version of that number right there. And if I've got something that's a smaller number, like let's say I've got 0.000037, well, I could express that in scientific notation. This is a number less than 1. It's between 0 and 1. So again, we want to find that first non-zero. It's going to be 3.7 times something, times 10 to the something. Well, I'm going 1, 2, 3, 4, 5. That's 10 to the minus 5. And you'll see that numbers that are between 0 and 1 have negative exponents on them. Numbers that are larger numbers, tens, hundreds, thousands, millions, billions, trillions, they're going to have positive exponents on the power of 10. Here's one to try. Our national debt is $23 trillion. And of course it is getting bigger every day. Express this in scientific notation. Well, you'd have to know what a trillion is. I'll let you look that up and see. It's going to be 2.3 times 10 to some power here. And we need to figure out what that's going to be. So I'll let you do that, and that'll be the nice way to express our national debt, because it's so huge. We should be using scientific notation for it. So what is a trillion? It's 10 to the what? 10 to the what? That's not a negative sign. It's just 10 to the what? You figure it out. Okay, scientific notation, and one thing too about multiplying in scientific notation. Let's say I've got some number like 2.5 times 10 to the 6th, and I want to multiply that by 4 times 10 to the 3rd. What you can do is multiply those parts together, and then multiply those parts together, and turn it into scientific notation. So 2.5 times 4, that's an easy one. That's just 10. Times, I've got 10 to the 6th times 10 to the 3rd. That's 10 to the 9th. I'm just adding 6 and 3. You say, okay, well, this is okay, but it's not scientific notation. This number can't be 10. So what I will do is, if I want to make this 1.0, I essentially divide by 10. And if I divide that by 10, I have to make that bigger by a power of 10. So that's 1.0 times 10 to the 10. And that's proper scientific notation. Okay, last thing in your chapter, they're asking you to look at a couple of problems involving this equation. And this equation says distance is equal to rate times time. And I like to write it distance. I tend to use S for distance, R times T, or you could say D is equal to R times T, whatever. S in physics usually means the distance you've moved. So what they want to do is they want you to start practicing this equation. And if you take a look at rate, well, your distance is going to be in some units of length. And it could be meters, it could be kilometers, it could be miles. So your rate is going to be in length or distance per time, per unit time. So you might have meters per second. You might have miles per hour. You might have kilometers per hour. So when you're using these, you want to make sure your units are all good to go. So in this case, if I've got distance in meters, and I have my rate in meters per second, I want my time to be in second, so that the seconds would cancel, and I'd be left with my units of meters. So the example they give in the book, they say light travels at, they're using miles per second. It says light travels at 1.86 times 10 to the 5 miles per second. 1.86 times 10 to the 5 miles per second, or 186,000 miles per second. In metric, that's 3.0 times 10 to the 8 meters per second, if you happen to be interested in the speed of light. And the question is, it takes light 5 times 10 to the 2 seconds to travel from the sun to the earth. What is the distance between the sun and the earth? Well, distance is rate, 1.86 times 10 to the 5 miles per second, times 5 times 10 to the 2 seconds. My seconds cancel. I'll be left with miles, which is exactly what I want. So 1.86, that's going to be times 5. That's almost 2. So it's going to be 9.30 or 93.0. No, 9.3. Sorry. 9.30 times 10 to the 7 is going to be my distance, 93 million miles, which you well know. So this is the last video for chapter 1, and I'm going to give you some problems at the end of the chapter, and that's it for tonight. I figured that your problem solving should probably take you a good hour and a half, so you can go ahead and take a look at the problems I'm about to post.